Before we take any tutorial questions, we need to know what is rectilinear motion and what kind of feature it have. First, we can assume a particle walk along the straight line. We assume it's xso, and we call it p, and they have initial velocity, which is VO, and a V after a time of t. So we have several very important equations we need to know. First comes from velocity, which is V is equal to VO plus delta V. According to when the time is very small, time interval is very small, we could say V is equal to VO plus dV. According to the definition of acceleration, we say A is equal to change of velocity with respect to time. We got V is equal to VO plus A dt. Right here, dt means the change of time, which is time itself in most of questions. So we have V is equal to VO plus AT. Here's our equation number 1. The equation number 2 comes from the definition of acceleration. We can expand it by our chain rule. We'll find dx over dt is equal to V itself. So we have A dx is equal to V dV. Here's our equation number 2. To be mentioned that this one just used the definition of acceleration, so it can be used when acceleration is constant or acceleration is inconstant. It all can be used. The third equation comes from the integral of equation number 2. The boundary condition will be VO to V and x0 to x, because if acceleration is constant, we can take it out from the integral. So we have AX is equal to V squared over 2, VO to V. After taking out, we have V squared minus VO squared is equal to 2A delta X. Delta X means the change of distance, which is X in the most of the time. So we have, here's our equation number 3. Questions number 1. Packages enter the chute at A and come to rest at C. So I will say there are 2 pieces of rectilinear motions right here. From A to B, the acceleration comes from gravity and it be positive. From B to C, it comes from friction and it's negative. So let's collect all the given conditions right here. So the chute is 10 feet, so we have delta S AB is equal to 10 feet. The package at point A is 4 feet per second, so we have 4 feet per second. Acceleration at the chute is equal to 0.3 standard gravity, which is equal to 9.66 feet per second square. And also, the package and point C is at rest, so we have Vc is equal to 0. What we need to find is acceleration when it's at Vc, and also the total time. So from A to B, cause the acceleration constant, so we have square is equal to VA square plus 2A dot S. VB is equal to square root VA square plus 2A dot S, which is equal to 4 feet per second square plus 2 times feet per second square times 10 feet, which is equal to 14.46 feet per second. We have another equation we just got, which is VB is equal to VA plus AT. TAB is equal to VB minus VA divided by A, which is equal to 14.46 feet per second minus 4 feet per second divided by 9.66 feet per second square is equal to 1.083 seconds. So from B to C is also the acceleration constant. We have Vc squared is equal to Vb squared plus 2A delta S. So we take acceleration out. We have Vc squared minus Vb squared divided by 2 delta S Bc. Vc is equal to 0. So we have negative 14.46 square over 2 times 12, which is equal to negative 8.72 feet per second square. Another equation, Vc is equal to Vb plus AT. TBC is equal to Vc minus Vb. Vc is equal to 0. ABC is equal to negative 14.46 feet per second over negative 8.72 feet per second square, which is equal to 1.659 seconds. So the T total is equal to TAB plus TBC is equal to 1.083 plus 1.659, which is equal to 2.74 seconds. Question number 2. The steel ball slides free on the rod with the effect of electromagnet, and it has the acceleration of A is equal to K divided by L minus X squared. Right here, K and L are constant, so we need to find the boundary of X. As from the question, we know that the ball is released from rest at X equal to 0, so we have X equal to 0 right here. And we need to determine the velocity when it strikes the pole face, which is right here, which is, we assume that this length is xb. We need to find the velocity of the steel ball at xb. And also xb is equal to L divided by D over 2. Because the acceleration is change all the time, so we only have used this equation. Takes integral from 0 to VB, from 0 to XB. Acceleration is equal to k divided by L minus x squared. Right here we need to use the substitution method. We let u is equal to L minus x, take the derivative, which is equal to k over u. So we can solve this equation. So VB squared over 2 is equal to k divided by L minus xb minus k over L. After rearrange it, because xb is equal to L minus D over 2, so we have VB is equal to 2 square root k times L minus D over 2 divided by LD. Before we go any further, we need to know another two kinematic function. We could start from dx when the time interval is very small. Dx equal to v dt. Takes the integral from x0 to x and 0 to t. So we can get x equal to x0 plus v0t. Here's our equation number 1. So let's do that again. From dx equal to v dt, we already know that v is equal to v initial plus at. We take the integral again. To x0 plus v0t plus 0.5 at squared. Here's our function number 2. Question number 3. A marksman fire practice from A towards B, and it has a diameter of 160 millimeter, which is equal to 0.16 meter. And also got the initial velocity, which is equal to 900 meter per second. And also the distance from A to B, which is equal to xb is equal to 1500 meter. What we need to find is the range of theta. Theta right here is the angle of shooting. So we can draw a diagram right here. We set the marksman at the origin. here is our YB. If we reach the bottom of the target, here is theta 1. If we change our angle, we will reach the bottom of the target. We call this theta 2. So let's get started. When we reach the bottom of target, YB is equal to negative 0.08 meter. So we can use the formula we just got, which is XB is equal to XA, which is equal to 0 because A is origin, plus VXOT, and we have 1500 is equal to 900, because right here we need the velocity at the x direction, so we should times cosine theta and t. And also YB is equal to YA equal to 0 plus VYOT minus 0.5 gravity t square. Right here the acceleration is just the gravity, so we can just put this negative standard gravity right here. So we have 0.16 over 2 is equal to 900 sine theta t minus 0.5 9.81 t square. When we solve these two equations, we will get t is equal to 1.667 second and theta is 0.517 degree. When the bullets reach the top of the target, we will say everything will be the same except the YB. Right here, YB is positive. It's equal to 0.08 meter. Same equation, just change YB. So we got t is equal to 1.667 seconds and theta is equal to 0.524 degree. So we could say the range of theta is from 0.517 degree to 0.524 degree. Question number 4. A freighter is moving at 4 meters per second. After the engine is shut off, it decelerates by negative kv square. So we have A is equal to negative kv square, and initial velocity is equal to 4 meters per second. And also it takes 10 minutes to reduce its speed to 2 meters per second. So t is equal to 600 seconds, and v 600 seconds is equal to 2 meters per second. What we need to find is v, the general form of vx, and also the distance after 600 seconds. So because acceleration is changed all the time, we need to start from the definition of acceleration. We already got this negative kv square, and we have this form, takes the integral. T is from 0 to 600 and v is from 4 to 2. So we have k is equal to 1 over 2,400. Because we need to get the general form of velocity, we need just directly integrate it without the boundary condition. So we already got k. Vt is equal to kt plus c and 1. There's another boundary condition. which is when t is equal to 600 seconds, v is equal to 2 meters per second. So we put it in. We got c is equal to 1/4. After we got these two constants, we will have Vt is equal to 1/400, 2,400 t plus 1/4. That is the general form of velocity. And after that, we can start from the definition of velocity. Put it in. And we could take an integral of it. We should use the substitute method again right here. We let u is equal to t over 2,400 plus 1/4. So du divided by dt is equal to 1/400, 2,400. We got this form. Substituting to our equation, we have natural log u. So put it back into our equation. 42400 natural log plus c is equal to x. Right here we have boundary condition right here. When t is equal to 0, x is also equal to 0. So we got 2400 natural log 1/4 plus c is equal to 0. C is equal to 3327. Put it back into our equation. So we got x is equal to 2400 natural log t divided by 2400 plus 1/4 plus 3327. What we need to find is the distance when the time is 600 seconds. So we have t is equal to 600 seconds, x is equal to 1663 meters. That is our final solution.